Hello friends, welcome to AS Tutorials. Today we are going to solve some problems on dynamic error coefficient method. For system shown in figure, find the error using dynamic error coefficient method for input of 6 plus 5t plus 6 by 2 t square. And this is the block diagram given. From this, we need to determine the dynamic error. In this closed loop system, he has given 3 blocks. You can see in first block with a value 15, and in the second block 20 into s plus 1 divided by s plus 2 into s plus 5, and in the third block he has given 0.2 divided by s plus 1. Now this to get g of s, we need to combine all these 3 blocks. So by doing that, we'll get 15 into 20 into s plus 1 into 0.2 divided by s plus 2 into s plus 5 into s plus 1. In this and this get cancelled. We'll get here 15 into 20 into 0.2, 60 divided by multiplying these two, we'll get s square plus 7s plus 10. So now by combining these 3 blocks, we got a value 60 divided by s square plus 7s plus 10. 60 divided by s square plus 7s plus 10. By cascading these 3 blocks, we got a value of g of s, and you can see here h of s value is 1. So in this problem we need g of s and h of s. We'll substitute this further. You can see in the problem he has given the input value 6 plus 5t plus 6 by 2 t square. By considering this input, we will write the dynamic error formula, the limit of the dynamic error formula. Let us see. First, the input is given r of t is equivalent to 6 plus 5t 6 by 2 t square, which is nothing but 3t square. Now by differentiating this input r dash of t, we'll get this term will become 0, constant term, and from this we'll get 5 plus, and in this we'll get the differentiation of 3t square is 2 into 3, 6t. Further differentiating r double dash of t, we'll get this constant becomes 0, and from this we'll get 6. Now further if I differentiate, I will get 0. We'll stop here. You can see here the given input r of t is equivalent to 6 plus 5t plus 3t square, and the differentiation of that r dash of t is equivalent to 5 plus 6t, and differentiation of above, that is r dash of t, we are getting 6. So looking into this, we'll write the formula, dynamic error formula. ESS of t is equivalent to k naught r of t, k naught into r of t plus k1 divided by 1 factorial into r dash of t plus k2 divided by 2 factorial r double dash of t. So looking into the input given, we have written the steady state error formula. We have stopped at k2 2 factorial r double dash of t. Now in this we need to calculate k naught value, k1 value and k2 value. K naught formula is k naught is equivalent to limit s tends to 0 f1 of s, where f1 of s is equivalent to 1 divided by 1 plus g of s into h of s. So we know what is g of s and h of s from the given diagram. Let us see by substituting this what we are going to get f1 of s. f1 of s is equivalent to 1 divided by 1 plus g of s into h of s. You can see here g of s is 60 divided by s square plus 7s plus 10, and we know that h of s value is 1. By taking LCM, f1 of s is equivalent to 1 divided by s square plus 7s plus 10 plus 60 into 1, 60 divided by s square plus 7s plus 10. Taking this denominator to the numerator, will get f1 of s is equivalent to s square plus 7s plus 10 divided by this value. By adding this 10 plus 60 will get 70, so s square plus 7s plus 70. This is f1 of s value. Now with the help of this f1 of s value, we will calculate k naught, where k naught is equivalent to limit s tends to 0, f1 of s is equal to limit s tends to 0, s to the power 2 plus 7s plus 10 divided by s to the power 2 plus 7s plus 70. So by applying limit to this, you can see that this term and this term will become 0, this term and this term will become 0. We'll get 10 divided by 70, whose value is 10 divided by 70 value is 0.1428. This is the k naught value. Next we'll calculate k1 value. K1 formula is k1 is equivalent to limit s tends to 0, differentiation of f1 of s with respect to s. We know that f1 of s value is this, differentiating with respect to s, limit s tends to 0 d by ds s square plus 7s plus 10 divided by s square plus 7s plus 70. Now you can see this, it is in u by v form, and we know for u by v constant, differentiate u minus v by v differentiation, v constant differentiate u minus u constant differentiate v divided by v square. Now in this case this term is u and this is v. By considering that, we'll get k1 is equivalent to limit s tends to 0, v constant s square plus 7s plus 70 into differentiation of u 2s plus 7, 2s plus 7 minus u constant s square plus 7s plus 10, differentiate v, and in this we'll get 2s plus 7, 2s plus 7 whole divided by v square s square plus 7s plus 70. So k1 is equivalent to limit s tends to 0. Simplifying this above term, we'll get 60 into 2s plus 7 numerator value. By simplifying this, we'll get divided by s square plus 7s plus 70 whole square, and this will be equivalent to, by applying limit s tends to 0, we'll get 60 into 7, which is nothing but 420, divided by, so you can see that in this case this and this will become 0, we'll get 70 square. So here we'll get a value of k1 which is equivalent to 0.0857. So here we got the k1 value. K1 is equivalent to 0.0857. Next we'll calculate with respect to the formula k2 value. K2 formula, k2 is equivalent to limit s tends to 0 d square by ds square f1 of s. So therefore k2 is equivalent to limit s tends to 0 d by d square, d square by ds square. F1 of s value is s square plus 7s plus 10 divided by s square plus 7s plus 70. And we know that in previous case we have calculated the differentiation of this value, that is limit s tends to 0 d by ds differentiation. Here in this case we know that 60 into 2s plus 7 divided by s square plus 7s plus 70 whole square. This is what we got by differentiating this term. Now we need to differentiate this again. Limit s tends to 0. Now again it is in u by v form. This v constant, s square plus 7s plus 70, this v constant, differentiate u. Differentiating u will get here 60 into 2, that means differentiating 2s plus 1, this becomes 0. From this I will get 2 into 60, I will get 120 minus, now keeping numerator, 60 into 2s plus 7, and differentiating this v term will get 2 into s square plus 7s plus 70 into 2s plus 7. So in the denominator we know that we are having s square plus 7s plus 70 power 4. Now in this we'll get further by simplifying limit s tends to 0. From this numerator you can see that I can rewrite s square plus 7s plus 70 whole square into 120 minus 60 into 2, it is 120, and then 2s plus 7 into 2s plus 7, I can write 2s plus 7 whole square, and then this term as it is s square plus 7s plus 70 divided by s square plus 7s plus 70 to the power of 4. Now by applying limit s tends to 0 to this and this will become 0. We'll get 70 square into 120 minus, in this case this becomes 0, 120 into 7 square, and from this I will get plus, this I will get into 70 divided by, in this two terms become 0, from this I will get 70 to the power of 4. Therefore K2 is equivalent to, will get somewhere here the value equivalent to 176,400 divided by 70 power 4 value is 24010000. So by simplifying this, we are getting a value of 0.00734. So therefore K2 value is 0.00734. So we have calculated K0 value, K1 value and K2 value. Now we are going to substitute this in the formula, and we know the formula ESS of T is equivalent to K0 into R of T plus K1 into K1 by 1 factorial into R dash of T plus K2 divided by 2 factorial into R double dash of T. So in this we know the value of K0, K1, K2 just now we have calculated. I will write down that value here. K0 value we got 0.1428, K1 value I got 0.0857, and K2 value I got 0.00734, and we know R of T is equivalent to plus 5t plus 3t square, where R dash of T is equivalent to, we got 5 plus 6t, and R double dash of T is equivalent to 6. By substituting these values in the above formula, we will get ESS of T is equivalent to, K0 value is 0.1428 into 6 plus 5t plus 3t square plus K1, and 1 factorial is 1. K1 value is 0.0857 into the R dash of T value is 5 plus 6t plus, next K2 divided by 2. K2 value is 0.00734 divided by factorial, 2 factorial is 2, R double dash of T is 6. Now multiply this each term. ESS of T is equivalent to 28 into 6, we'll get 0.8568 plus 0.1428 into 5t will get somewhere 0.714t plus and 3t square into 0.1428 will get somewhere 0.4284 t square plus 0.0857 into 5 will get 0.428 plus 0.0857 into 6t will get 0.5142t plus and next 0.00734 divided by 2 into 6 will get 0.02238. Now in this you can see that just consider all t values, t square and constant values, this and one t square value is there and two t values are there. So therefore ESS of t, I will write first t square value, that is 0.4284 t square plus by adding this t value and this t value I will get 1.2242 t. Next by adding these constants, this and this, I will get somewhere 1.3073 value. So this is the dynamic steady state error. Hope you understood this problem. For more such videos, like and subscribe my channel. Thank you.